Hey, welcome to Dakota Prep's video for calculating the general lighting load for a house. Now, once again, we're going to use this question over here to the right to tackle this problem. It says, what is the subject anyway, I wouldn't say a problem, the subject. Okay, so the question says, what is the general lighting load for a 4,200 square foot single family home with 3 small appliance branch circuits and 1 laundry circuit? That is a big old house. So let's find our general lighting load for this house. So we know that we're going to be in Article 220. Hey, we're finding service size, or how the general lighting load is going to impact the service size anyway. So if we look in section 220.41, it says, hey, your unit load for a house is 3 volt amps per square foot. Okay, so we have 3 volt amps per square foot. 3 volt amps per square foot. So now we just need the square footage for this house, which is 4,200. So our unit load, or our minimum lighting load, that is 4,200 square feet times 3 is 12,600. Okay, so that's the first place. That's the first thing that we need to do. What did I just say it was? 12,600? Indeed it is, 12,600. Volt amps, right? But if we look at 220.45, it tells us, well, actually you don't need all that. The first 3,000, we need all of that, 100% of that. But after that, all of our, any load that we have beyond the 3,000, we only need to account for 35%. What they're really saying is, hey, we know you're not going to have all those lights on, and you're not going to be using all those receptacles all at the same time. So you don't need all of that power for your general lighting load. Now, before we run into that, this question also says we have 3 small appliance branch circuits and 1 laundry circuit. So if we look at section 220.52, it says, hey, those small appliance branch circuits for your kitchen and that laundry circuit, that can actually be added into this general lighting load, and we can apply those 220.45 derating factors, right? So to 220.52 says, hey, each of these circuits, right, needs 1,500 volt amps. That's the demand that we apply to these circuits. So we've got 3 small appliance and 1 laundry circuit, right? So we got 3 small appliance plus 1 laundry circuit is 4 circuits total, right? Times 1,500 volt amps. So we've got an additional 6,000. That's 1,500, right? 6,000 volt amps that we can add in here with our 12,600 for our minimum lighting load. Now we can apply those derating factors found in 220.45 to all these, right? So we got, okay, 0, 0, 6, 8, so 18,600. Okay, so table 220.55, I'm sorry, not 55, 220.45 that is. Says, hey, first 3,000, let's go ahead and get rid of those right now. Okay, that's got to be 100%. We'll add that back in later. So we have 15,600 volt amps. Okay. Move this over, 18,600 minus 3,000 is 15,600. Now we can apply that 35% demand factor to that, so that leaves us with 5,460. But remember, we have to add that 3,000 back in there. We can't forget about that. That's 100%. So 8,460 volt amps is our demand factor, which means the green light, the green ink, correct version, right answer is 8,460 volt amps.